Hey Algebra 2, today we're going to teach you how to divide polynomials. And we're skipping over something called long division, and we're going straight into a shortcut called synthetic division. All right, so what's the purpose? The purpose of doing division is to find roots, factors, zeros, x-intercepts. Remember, these are basically equivalent statements. This says if x minus b is a linear factor of a polynomial. All right, so you don't like it when it looks like this. Let's say it looked like this. X minus 5, x plus 3. All right, so these are linear factors of my quadratic polynomial. This says then b is a zero, root, or solution. So if x minus 5 is a factor, then that means x equals 5 is a solution. If x plus 3 is a factor, then x equals negative 3 is a solution. So that's all that fancy thing was saying. It says, what are the zeros of this polynomial? So if we want to figure it out, we are going to factor it. So we have to we're going to make an ACB chart. Remember, A is 1, B is negative 5, and C is 6. So when I make an ACB chart, I'm taking the A term times the C term. I want factors of 6 that add up to negative 5. If I want factors of a positive number, that means these are either both positive or negative. I can play with 6 and 1. And 2 and 3. 2 and 3 adds up to 5. And then a negative times a negative equals a positive. And that is my winning combination right there. So I'm going to get rid of the y. And I'm going to replace it with a 0. And then this right side factors like this. X minus 2 and x minus 3. So these are what we would call the linear factors. And then if x minus 2 is my factor, that means x equals 2. And if x minus 3 is my linear factor, that means x equals 3. And these are called my solutions. Zeros, x-intercepts. All right, so just to give you a visual, since we've been graphing, it'd be probably helpful to see what it is. So that means my graph crosses the x-axis. 1, 2, 3, 4. Right here at 2. And right here at 3. And then my y-intercept is right here at 6. And if I were to try to sketch this out, though, this is going to be ugly, and it looks something like that because that is not drawn to scale. But that is how you can use a combination of factor form and standard form to sketch yourself a graph. This says, what are the zeros of this? So fake out that 0 and change it to, or y and change it to a 0. So once again, these are called the linear factors. That means x equals 2, negative 2. If my factor is x minus 1, that means my solution is positive 1. And if my factor is x minus 3, then that equals 3. And that means that these are my solutions, zeros, x-intercepts. So the question is, like, if I have something higher than a quadratic, you can't make an ACB chart, I wonder what I can do to figure out how to graph this thing. And the process is called synthetic division. It's a procedure to divide a polynomial by a binomial using coefficients. All right, so step 1 says, write the coefficients of the dividend. This is the dividend, the bigger one, in order of decreasing exponents. Include 0 for any missing x term. So we've talked about filler zeros before. So if you have a missing term, you have to put a filler 0 in. This goes x to the second, and then the first, and then the constant. This one doesn't need a filler 0. It's in perfect order. All right, so we use the coefficient. So the coefficient is 1, 3, and -40. Those are my coefficients I'm going to use. All right, so here's the way we do this. You take the linear factor and you write it as the solution. So if this linear is x minus 5, then we're going to use x equals 5. So if it gives it to you as a linear or binomial, you have to basically solve it, and 5 is going to be the number we use in this process. All right, so here's what it looks like. This 5 is called the divisor, by the way, when you're reading the notes here. So you put the divisor in this little box. It says you bring down the coefficients. So my coefficients are 1, 3, and -40. So we write them down, give a little space in between of them. We're going to put a row of numbers here, so we're going to give ourselves a little bit of room. It says bring down the leading coefficient. So we're going to bring it straight down. It says multiply the leading coefficient by the divisor. So you're going to take 5 times 1, and then you put the answer under the next coefficient. 5 times 1 is 5. It goes right there. Add down. It is always add down. 3 plus 5 equals 8. Repeat the process. 5 times 8 is 40. Add down. -40 plus 40 equals 0. Oh yeah, you're supposed to put like this line here, and whatever number is right here is what is called the remainder. It says put the variables back into the answer. So we used the coefficients up here and we took away the variables. So we're going to put the variables back in the answer. And the answer is x plus 8. All right, here's what you need to know. Something is a factor if the remainder is 0. Like, let's say it looked like this. If you have 15 divided by 3, you get 5. So I know 3 is a factor of 15 because it goes in there evenly and there is no remainder. So that's what the importance of remainder is that it tells me whether this is a factor of this or not, and it is. So when the remainder equals 0, that means that x minus 5 is a factor of x squared plus 3x minus 40. We'll do a few more and it starts to make sense. All right, it says, do we have any Does everything go in descending order? So my exponents go 3, 2, 1, and then a constant. So they go in order. My linear factor is x plus 2. That means I'm going to use -2 as my divisor. So I put my divisor over here in a box, and I'm going to write out my coefficients. 2, 3, -4, 15. Give yourself a little bit of room. Draw a bar and write the word remainder here. We are trying to figure out if x plus 2 is a factor of this polynomial. If you get a 0 here, yes, it's a factor. If you get any other number, then it's not a factor. All right, here's how it goes. Step number 1, bring down the leading coefficient. So this, what we have down here, is basically our answer row. What you have down here, it's basically the answer you're looking for. Step 2, we're going to multiply this number right here by the bottom row. -2 times 2 equals -4. So then it goes in the next spot. And then you always add down. 3 plus -4 is -1. Now multiply again. -2 times -1 is 2. Add down. -4 plus 2 is -2. Multiply. -2 times -2 is 4. Add down. 15 plus 4 is 19. All right, so here's what I know. I have a remainder of 19. So I know that x plus 2 is not a factor of the polynomial because my remainder is not 0. I have a remainder of 19. But I do have to divide this, and I have to write out my answer. So when you write your answer, these are the coefficients, and then you put in the variables, and you start with one less than what you started with. So I started with x to the third. This answer is an x to the second. And then from there, they go in descending order. -1x minus 2, and I have a remainder of 19. So you write remainders, you have to think back to like 5th grade math or something, as 19 over x plus 2. So why did I do 1 degree less than what I started with? So if you take everything else off and you just had 2x to the third divided by x, when you divide variables, you subtract your exponent. So that gives me 2x to the second. So we always start with one less than what we started with because when you divide variables, you subtract exponents. And that's why we did that. Let's try another one. All right. Make sure that these go in order and you don't have any missing x's. So I have a 4, a 3. Oh, I'm missing an x to the second, an x and all right, so let's rewrite this out neatly. 6x to the fourth minus 8x to the third plus 0x to the second plus 12x minus 14. So your exponents have to go in descending order, and if you ever have a missing one, you have to put in a filler 0 or it will not work. missing x equals filler 0. I have a linear of x minus 2. That means I'm going to use 2 as my divisor. So let's set it up. This linear, you change the sign and it comes right here. Now we're going to just write our coefficients down. 6, negative 8, 0, 12, negative 14. So this is how I want you to start setting it up. You have your, was that the divisor, I think? You have that number that goes here, and then you put the coefficients in order with no variables. And you have room for another row of numbers. So down below here is basically going to be your answer line that we're going to use. Right under the very last number, you're going to put like this little bar. You're going to write the word remainder. So the very last number right there is super important. Step number 1, your first coefficient comes straight down, always. And then the pattern is multiply, then add. 2 times 6 is 12. Add down. Negative 8 plus 12 is 4. Multiply. 2 times 4 is 8. Add down. 0 plus 8 is 8. Multiply. 2 times 8 is 16. Add down. 12 plus 16 is 28. Multiply. 2 times 28 is 56. Add down. Negative 14 plus 56 is 42. So here's what I can say. I have a remainder of 14. I know that x minus 2 is not a factor of this original polynomial. But I had to divide it. So when I divide, I put my variables back in, starting 1 degree less than my original. So I start off with an x to the 4th. My answer starts x to the 3rd, and then it goes in decreasing order. Plus 4x squared, plus 8x, plus 28. I have a remainder of 42, so I write that as plus 42 over x minus 2. Why am I writing it like this, you might ask? All right, let's do an easy one. Let's say that I had 9 divided by 2. 2 is not a factor of 9 because it doesn't divide evenly. There's a remainder, there's a leftover. So 2 goes into 9 4 times with 1 left over. So the remainder, or the 1 left over, goes here in the numerator, and then the denominator is this, which is this. And so that's why I write it like this. Let's try another one. Check your exponents, first of all. 3, 2, 1, nothing. And I wrote it wrong, sorry. There's supposed to be a divide sign in between there. All right, so I have x plus 2 as my factor. That means I'm going to use negative 2 as my divisor. All right, so there's an invisible 1 in front of there, so my coefficients are 1, negative 3, negative 4, and 12. You bring your first coefficient straight down, and then the pattern is multiply. Negative 2 times 1 is negative 2. Add down. Negative 3 plus negative 2 equals negative 5. Multiply. Negative 2 times negative 5 is positive 10. Add down. Negative 4 plus 10 equals 6. Multiply. Negative times positive is negative 12. Add down, you get a 0. Oops, sorry, I forgot that part. All right, so I have a remainder of 0. I can tell you for certain that x plus 2 is a factor of this original polynomial. And when I divide this, put your variables back in. It is 1x squared minus 5x plus 6. And I can tell that x plus 2 is a factor because my remainder is 0. Be able to state that fact. Ooh, number 5. Here's a hard one. All right, so far everything else was a linear term. And there was no number in front of that. This is still a linear term, my bad. So I have 2b minus 3. Okay, so what am I going to use? Well, you can't have a number here in front of the b. Think of divide and slide, like reverse divide and slide. We're going to slide that to the bottom. So that would be the same as b minus 3 halves. If 3 halves is your factor, then that means 3 halves is my divisor that I'm going to use. Now let's check and see if you need filler zeros. My exponents go 4, 3, oops, there's no 3. So 4b to the 4th plus 0b to the 3rd. I have a second. I have a first. All right, so I had to add filler zeros. At b to the 3rd. Now I'm ready to set it up. So 3 halves is my divisor. My coefficients are 4, 0, negative 17, 14, and negative 3. Under my very last term, I put that little bar and the word remainder. So I'm looking to see if I get a 0 here or not. We're going to bring our first one straight down. And here you either need to be good with fractions or your calculator. We are multiplying. You are taking 3 halves times 4, or 4 over 1. That gives me 12 halves, which equals 6. 3 halves times 4 equals 6. And now you add down. 0 plus 6 equals 6. Multiply. 3 halves times 6 is 18 halves, which equals 9. 3 halves times 6 equals 9. That goes there. And add down. Negative 17 plus 9 equals negative 8. Multiply. 3 halves times negative 8 over 1. It's negative 24 halves, which equals negative 12. 3 halves times negative 8 equals negative 12. It goes right there. Add down. 14 plus negative 12 equals 2. Multiply again. 3 halves times 2 over 1 equals 6 over 2, which reduces and equals 3. And when you add down, you get a 0. All right. What is the answer here? So we're going to put the variables back, starting with your exponents one less than what you started with. So 4b to the third plus 6b to the second minus 8b plus 2. And I can say that 2b minus 3 is a factor because my remainder is 0.